See, I think it's funny to say confounded experiment because it's kind of an old cartoony way of swearing is to say confound it. Confounded experiments are experiments where an extraneous variable is varying systematically with the independent variable. So we have the real variable that we're manipulating and that we think is important. And then we have this other one that is not part of the experiment, but is systematically varying with our independent variable. So here's an example. Let's say that we have assigned participants to either bottle feed or breastfeed their baby. And in case you're thinking, wait, how do you randomly assign somebody to bottle feed? You can ask them to put, even maybe they wanted to nurse, right? Well, you can put your breast milk into the bottle, right? So we can do it like that. So we've got bottle feeding as the independent variable. And we've got diarrhea as the dependent variable. Well, this is a charming example. Jill, thank you for pulling this one up. Okay. So if we're looking to see whether bottle feeding is causing diarrhea, we might be thinking there's all these things about the bottle feeding that could be the culprit, right? That, breastfed babies have lower rates of diarrhea than bottle feeding babies. Maybe bottle feeding has, like, the nutrients aren't the right balance for a baby and it's giving them diarrhea. Maybe the water that you mix the formula with is tainted and that's causing diarrhea. Maybe the bottles weren't correctly sterilized and that's causing diarrhea. So there's all these things that we could go down the rabbit hole of trying to figure out what the bottle feeding is doing that's causing diarrhea. When in fact it might be that there's something else that's causing both the decision to bottle feed or the decision or the effect of diarrhea, like maybe mom's education level, right? Like moms with more education in the US tend to be more likely to breastfeed. Those with lower levels of education are more likely to bottle feed, and maybe also lower levels of education put you into a part of the city where the pipes are older and so the water is kind of somewhat you see where I'm going? Like maybe there's something else that is varying along with the independent variable, and that's what's messing up. Even if we randomly assign the bottle feeding and the breastfeeding, the implementation might be in some way impacted by some third variable, and that's what's causing the outcome. It's not the bottle feeding that's determining diarrhea. It's this other compound. I just named mother's education, but just something else is causing it. All right, well, I thought it would be useful to check out this example of a confounded experiment, and I'm going to watch it with you, and what you're going to do is try and think of anything other than what is the claim. The claim is that the horse can count. The claim is the horse can do cube and square roots. It's worse than the claim that it can count. They're claiming it can do cube roots and square roots. Okay, so that's the claim. I want you to be looking at anything else that you think of that can possibly be a better explanation for what's happening in this video.
Square root of 1. Got it? Square root of 1. Yes, it's 1. Square root of 25. Square root of 25. Alright. Keep going. Square root of 9. Square root of 9. 3. Yes. And that. Square root of 81. Square root of 81. Nice. Yes. That's simple. Square root of 36. Square root of 36. Yes, it's 6. Good boy. What's the cube root of 216? Cube root of 216. Cube root of 216. Yes, it's 6. Good boy.
I'm sure that's good enough that you've got some hypotheses in mind by now. It's kind of a funny one to watch because it's like, okay, she's got different colored numbers. That's something I can check on. She's got right hand, left hand. That's something I can check on, right? Maybe there's something about the way she's holding the cards and she's giving cues with her finger positions. Maybe I think she's doing a pretty good job of trying not to do what's called the clever Hans effect, where she's giving some kind of subtle cue by like looking at the one that's right or something like that. I can't see any of that. Of course, they've zoomed in pretty close for this demonstration, and so maybe she's doing something with her feet. I've had students hypothesize that maybe there's somebody standing behind the horse touching one side or the other side of the horse to indicate which one's the right answer. I mean, that's possible. Maybe she's got some kind of food behind the correct answer. I mean, it could just be a like complete trick. It's not even a confounded experiment. It might be a complete trick. What I was hoping to do is just foster some thoughts in your head and have you think to yourself, what else besides the so-called independent variable of, math skills, basically could be explaining what's going on in this video, right? And what's going on is probably some combination of things that crossed our minds. I don't know exactly what it is. It could just be that she always, every single time she does this, goes in the exact same order. I mean, there's really simple things that the horse could probably remember that could explain why it appears that the horse is doing square roots and cube roots. I don't know about you guys, but I didn't know the cube root of 216. I thought it might have something to do with the 6 because I figured what else could end up with a 6 at the end. But I mean, I didn't know it. And so it's kind of fun. I don't like it that a horse maybe knows better than we do. But anyway, on to the next part of this. So an extraneous variable is a variable that varies systematically with the IV. Okay, I already said that on the previous slide. When we have a confounded experiment, the results of that experiment could be due to the independent variable. It's possible that the independent variable is working and it is what it looks like. And we can confidently say this caused that. But the problem with a confounded experiment is it could be that the confound is what's causing the outcome. So what we need to do when we're designing studies is, to the best of our ability, protect against confounds, right? Because when we have this differential explanation, could be the IV, could be the confound, it makes it impossible to draw a cause and effect conclusion. We don't know what's causing the outcome on the dependent variable. And we don't want to be in that circumstance. We want to have an outcome that is clear, right? That there is no other logical explanation except for the independent variable. So, just reiterate what I said before. Let's look at this example. Let's say that we found in our experiment that people's memory, the dependent variable of memory for pictures, was better than the memory for words. Okay, so memory is the dependent variable. The independent variable is the stimuli being pictures or words. So this could be a within subjects design, right? Or repeated measures where the same people see pictures sometimes, words other times, and then produce their memory for them. It could be between subjects design where some people saw pictures and some people saw words and then all of them took a memory test. Could be either way, but anyway, we've got this independent variable of stimuli, either pictures or words, and the dependent variable of memory. It's possible that the independent variable is responsible. Pictures are in fact more memorable than words. It's possible that the design is what we claim it to be. It could be that there's some kind of extraneous variable present. Maybe the slides that contain the pictures are more detailed, right? Words are just words, whereas pictures have more, don't they? They have details. Like when you hear the word vase, you're generating in your mind maybe an image of a vase. But when I show you a picture of a vase, it might have more details than the one that you generated in your own mind, right? And that might make it more memorable, might make it more distinctive, easier to remember. So now, just for closure's sake for you, I did a lot of research on picture versus word processing when I was in graduate school. And the good news is there's a million studies that have chased down all of the extraneous variables. And basically left us with the conclusion, if you correct all of these extraneous variables, what we are left with is that pictures are more memorable than words. So I just give you closure on that result, but because I don't know about you, I like to have closure. All right, so it's possible that that the outcome is due to either independent variable or confound, and we just really don't know. So I'm going to let you watch this little video about facilitated communication for people with autism or with locked-in conditions and stuff like that. And then I will see you on the other side, and we will discuss whether that's an example of a confounded experiment.